Am I audible, sir?
Very much, very much, very much, sir. Vasu,
லேண்ட்ல கனெக்ட் பண்ண முடியாது உங்களுக்கு.
Good morning, Sarana Kumar. Good morning, Sarana Kumar.
Sir, good morning, sir.
Am I audible?
Yes, sir.
Yes.
Shall we start, sir?
1 minute, sir. 1 minute.
Okay. அதுக்கு இப்போ எப்படி வச்சுக்கணும் என்ன இப்போ உங்களுக்கு
Good morning, Chief Director, sir. Principal, sir, shall we start, sir? Principal, sir.
Yes, sir. Please go ahead. Please go ahead. Sir is available. CD, sir. Please
Okay.
go ahead, sir.
I request Aruna Kumar can start. Sir.
ஓகே சார்
Good morning, Chief Director, sir.
okay yeah very good morning to everyone present here. We, the Department of Automobile Engineering, welcome you all for 2 weeks faculty development program on advanced materials and manufacturing technology. Any event is incomplete without an invocation to God. So we began our session with Tamil Thai Valthu.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் மதனமென திகழ்வரத கண்டமிதில் கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு திரை முதலும் தரித்தனரும் திலகமுமே அத்திலக உன் சீரிழமை திறந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Department of Automobile Engineering was started in the year of 2014 with the vision to impart quality education, skills, and attributes based on the changing global standards and automobile industrial requirement. So the department functions with experienced and well-qualified faculty members. In addition to this, the department provides the students with value-added courses, workshops, seminars, guest lectures, and industrial visits to ignite the young minds and to trigger the spark of automotive engineers within them. Now, we would like to invite a man of distinct vision and a fountainhead of illuminating ideas, an idol of knowledge, experience, and inspiration to all of us. The head of the department, Dr. S. Satyamurthy sir, to welcome the gathering.
Thank you, Mr. Sarana Kumar. Am I audible, Sarana Kumar?
Yes, sir.
Thank you. Good morning to one and all, ladies and gentlemen. It gives me a great, immense pleasure to start this auspicious occasion. We heartily welcome you. On the outset, I thank our management for providing this opportunity to organize 2 weeks virtual national level faculty development program on advanced materials and manufacturing technology. We have received overwhelmed response from the participants from various parts of the country. The faculty members have registered for this national level faculty development program. Thanks for choosing our college and the department for participating, and on behalf of the Department of Automobile Engineering, it's my pleasure to extend a cheerful welcome you to all. Your presence makes us very happy. The capacity to learn is a gift. The ability to learn is a skill. The willingness to learn is a choice. I welcome Captain Professor Dr. A. Suresh Babu sir. He has served for various nations as a captain in defense for this in the government of India. and currently working as a head of the Department of Manufacturing Engineering, College of Engineering, Hindi. It's our privilege to have you as our guest of the day. With the immense pleasure and thank you for the welcome our speakers, Dr. Suresh Babu, to this event. Welcome you, sir.
மாஸ்க் எடுங்க உங்க மாஸ்க் எடுங்க வெளியில
Principal sir, please kindly mute it, sir.
சாரி
I welcome our Chief Director, sir. He is a great person with a huge experience and he supports and encourages abundantly. In this word, I welcome the Chief Director to this Faculty Development Program. Welcome you, sir. On behalf of our department, I would like to extend a warm welcome to our principal and he rise up, start fresh and see the bright opportunity in each new day. I welcome our principal, sir. He is a person who always motivate, encourage, support us in all our endeavors. Welcome you, sir. I extend my warm welcome to our Vice Principal Admin, Dr. Anandakumar sir, the Vice Principal Academic, Dr. Ilango sir, who always stand with us in all our activities. Welcome you, sir. I extend our welcome, our parent department, HOD, Dr. Vetrivet Chalian sir, to this national level faculty development. Welcome you, sir. I welcome our IQAC coordinator. I welcome all the head of the department who are always encouraging and supporting. Welcome all the head of the departments. Here, I wish to mention our faculty members who are always the backbone of success of any event. With the great pleasure, I welcome all my faculty members of Department of Automobile Engineering. I welcome our participants who are all set to make this event remarkable one. Once again, I want to heartily and wholeheartedly welcome you to this FDP and wish successful deliberations. It's my pleasure one more time to say thank you, welcome you all for the inaugural function. Welcome you all. Over to Mr. Saranakumar.
Thank you, sir. Now, we would like to call upon Dr. R. Palnichami, sir, Professor, Development of Automobile Engineering, to articulate about the Faculty Development Program.
Thank you, Saranakumar. Good morning to one and all present in this online digital platform. I am here to give the introduction about this FDP. The purpose of conducting this FDP on advanced materials and manufacturing technology is to upgrade the knowledge of the faculty, students, and the researchers in the field of materials and manufacturing process. All of us know that the efficiency of the power plant will increase with the maximum temperature of the cycle. But this maximum temperature is limited by the materials melting point. Suppose if we have the materials with the higher melting temperature, the efficiency of the plant can be increased and we can save the fuel, which helps in improving the country economy. In the field of aircraft, it requires 0.2 kg of fuel for 1 kg of additional weight for a distance of 1,000 kilometers. So if we reduce the weight of the materials used for fabricating aircraft, we can save the fuel. So we know the importance of the materials. With the above focus, developing low cost, low weight, higher melting temperature with sufficient strength is our focus. We, the Department of Automobile Engineering, Eastwari Engineering College, have organized this FDP for benefit of the researchers in the field of materials and manufacturing. I wish to highlight some of the topics covered in this topic. They are advanced manufacturing process, surface engineering, welding technology, nanocomposite material, surface modification, optimization techniques, materials characterization, tribology, mechanical behavior of the material, additive manufacturing, powder metallurgy, advanced machining process, surface coating technique, and development, synthesis of light alloy. So these are the topics we are going to cover in 2 weeks FDP. We hope that all of these topics will help the researchers to develop new materials to meet out the industrial need. Thank you.
Thank you, sir. The Department of Automobile Engineering provides 1-year student industry training program at Ashok Leyland. DST sanctioned rupees 52.8 lakhs for research project for the Department of Automobile Engineering. Our department produced 14 university rank holders, includes 1 gold medal. So Department of Automobile Engineering students have participated in national level Indian karting race 2020 held at Bhopal and runner-up in e-kart category. So now it's a time to invite our chief guest. The fragrance of flowers spreads only in the direction of wind, but the goodness of a person spreads in all directions. Admit us, we have such an inspiring personality. Our chief guest of the day, Captain Dr. A. Suresh Babu, ME PhD, Head of the Department, Department of Manufacturing Engineering, College of Engineering, Anna University, Chennai. On behalf of our management, I thank him for providing his gracious presence. Now, we would like to invite our FTB coordinator, Dr. U. Ilayarasan sir, to introduce our chief guest today.
Good morning, all of you. Today, our chief guest, Captain Dr. A. Suresh Babu, he is presently working in the Department of Manufacturing Engineering, College of Engineering, Anna University, Chennai. He has vast experience in teaching and research. He did Bachelor of Engineering in Mechanical Engineering from Alagapat Chettiar College of Engineering and Technology, Karaikudi. Master of Engineering in Industrial Engineering from Tyagarajar College of Engineering. He obtained his PhD degree in the Department of Manufacturing Engineering, College of Engineering, Anna University, Chennai. His area of interest are composite material, manufacturing processes, optimization, and additive manufacturing. He has published 185 research articles in conference and international journals. He received amount of 5 crores from the various funding agency like DST and UGC. Thank you. Now, I would like to invite Captain Dr. A. Suresh Babu sir to deliver inaugural address.
Thank you very much. Wonderful introduction. I don't know that how I am fit to words. It has been spelled out. Am I audible?
Yeah. Yes, sir. Yes, sir.
Thank you. Thank you. When I asked to be the chief guest for the inaugural function, as well as a resource person for one of the talk, maybe it will be continued with this inaugural function. I thought that I can share what is the engineering education today, because these kind of functions are programs which are designed with some objectives. We have to refine based on the situations, particularly Tamil Nadu, engineering education. What is today's education? So what should be the coming days? So it is our duty to envision the future and to use the knowledge which has been gained from your vision to predict the roles of engineers they are going to play to define the future. There are 2 aspects in which we can look at. One is relating to the development, the vision of engineering, and the work of the engineers going to define by the education which has been provided to them. Second one is what the actions, what are the steps we have taken from the education as educationalists to prepare these engineers for the future. So these are the two things we have to look at. There are questions which are coming into mind of any engineering faculty. What is there for changes which has been incorporated in the engineering curriculum in the last few decades, and what has to be done in the coming years? Into my mind, what will or should engineering be like in coming years? Will it be reflect whatever we covered the name of engineering today by the pattern what we followed the last decades? Can the engineering profession play the role in shaping its own future? Whether the future can be created is broadly recognized image that celebrates the exciting roles that engineering plays to address the social and technological challenges. And whether we have educating the engineers to be leaders so that there will be a balance and by implementing the new technologies with the vulnerabilities which again created by the engineers by the byproduct already as a result of the engineering solutions made to this world. And whether the engineering can be considered or a foundation to prepare the citizens or to celebrate the diversity of requirements of the citizens. So these are the questions which were coming to my mind, maybe which is very similar to your thought process also, because we are facing a lot of challenges in engineering education today. So the base change which has been occurred for the years, and what is the rapid change which has been occurred in these years is entirely different. So we cannot wait for any kind of things which will come and make revolution on our own engineering field. So we have to look at the following scenarios. Based on that, we have to react. The next scientific revolution or biotechnology revolution or the natural world replications. In addition to that, the globalizations has to be concentrated so that you can have an exciting vision for its future. And engineering education can be transformed to achieve this vision and can be a clear image built on the engineer's mindset and innovative developments, which is really going to address the rapid changes which has been occurred in the global scenario. And the ways we have to find out to focus all our energies in different engineering field, as this program is conducted by automobile engineering with the disciplines of manufacturing technology has been incorporated. They must know, the automobile engineers also should know the manufacturing part of their own parts which has been utilized for making automobiles. And surface engineering, this is going to whatever the knowledge is gained is really going to help them to achieve efficiency in their processes as well as in the products. I hope, considering all these facts, these kind of programs are designed by the organizers and it has been really going to be delivered by the speakers in the coming days. I wish all the best to the participants, and I wish the coordinators for taking step to update the informations in the mindset of trainers. So training the trainers is very important. Took that pain to train the trainers. I wish all the best. Thank you. Jay.
Thank you, sir. Thank you for your provoking address. It's my turn to extend a gracious and inclusive welcome to an eminent administrator and a man with a sense of commitment which creates an apt platform for us to grow. On this great morning, with the merging of mind, we welcome our Chief Director, Dr. N. Seduraman, sir, to felicitate the address.
Am I audible?
Very
Yes,
much
Am I
sir.
audible? Okay,
Yes, sir.
okay.
Yes, sir. Go ahead,
Uh,
sir.
Distinguished chief guest, Principal Professor Kumar, and Head of the Department of Automobile Engineering, Isur Engineering College, Dr. Satyamurthy, and all my members of the faculty and participants from various colleges and universities. Very good morning to everyone. Indeed, I am really happy that I have been asked to associate myself with this program in this faculty development program. As said by the chief guest, we have many challenges. To overcome these challenges, research being carried out, discussions are going on, faculty development program like on advanced materials and manufacturing technology. Such a kind of programs are organized in higher education institutions, particularly in engineering institutions. There are many challenges when you talk about the advanced materials and manufacturing. As said by the chief guest, you should also think of the environmental problem, the pollution. You may remember a few years before, in the capital of our country, Delhi, they have not permitted inside Delhi Corporation vehicle using a fuel which causes a lot of problems to the environment. Then they were all directed to use a particular fuel. And even the government vehicle, but transport also, it is in green color. The petrol bunk also in a different color to identify this type of petrol is available. Why I am saying automobile engineering, it is growing. Now, if you see the population of any city, it is doubling, tripling, vehicles are increasing. It causes other issues also. Being an automobile engineering student, he is interested in learning manufacturing and other technology. But at the same time, such a kind of faculty development program should concentrate on the issues faced by the people in the society. Today, we enjoy comforts, no doubt, due to the advancement of technology, due to science. We enjoy, but at the same time, there are issues, just like day is followed by night. Comforts or convenience is followed by difficulty, problems, issues like environmental, etc. Now you are Dr. Satyamurthy and his team, they have covered a wide range of topics. Thereby, faculty and students will get exposed to various information which are needed for this automobile engineering. I appreciate the efforts taken by the automobile engineering department and the faculty. As usual, our principal, Dr. Kumar, he always encourages whether they are not able to get full complement of students or not. Today, that is the condition. It's not only in Ramapuram, in all other places also. Probably a day may change, we may get full complement. But at the same time, Satyamurthy never gets dejected, disappointed because of this. He goes on organizing seminar, meeting, etc. Recently also, uh, they have an opportunity to have a tie-up with Ashok Lalat. Probably in his principal address or Satyamurthy may further develop on that point. What I am saying is the department is very active, doing a lot of academic activities. I wish they should do many more activities like this in the interest of the students and in the interest of the society, which is facing problems due to advancement, maybe in automobile engineering or any other engineering. I take this opportunity to thank the principal and his colleagues. I wish you all success in this program. Thank you. Thank you,
Thank you, sir.
Professor. Okay.
Thank you, sir.
Thank you, sir. Thank you for your thoughtful speech. Department of Automobile Engineering, sponsored by a Eco Sports Car by Ford India Private Limited for teaching learning process. Krita Car, sponsored by Hyundai Motors India Private Limited, Chennai, to the department for an initiative to industry-supported laboratory. And our department has sponsored by BMW Engine and Transmission System by BMW India Limited as a Skill Next initiative. Now, it's time to invite our principal, sir. One tree can start a forest. One word can frame a goal. One candle can wipe out the darkness. A true leader has the confidence to stand alone. Our principal, Dr. R.S. Kumar sir, his endless care, guidance, and support in all developmental activities of our institutions reflects his sincerity and leadership qualities. With a thankful heart, we request our principal sir to felicitate the address.
Thank you. Thank you, Saravana Kumar. Thank you, HOD. Thank you, automobile team, for inviting me for this awesome event. I wish to place on record my sincere gratitude to Dr. Captain Suresh Babu sir, as well as the galaxy of resource people that you have taken trouble pains to organize. When you go through the topic, firstly, it is so relevant, very rightly and correctly, aptly brought out by the chief guest. It's a very, very relevant area today we want, both materials as well as manufacturing. Both are of very high importance today, particularly with so many geopolitics and business orientation shifting towards China one policy. So now this becomes a very, very important area for research and knowledge sharing. Very good topic. I wish to congratulate the team Automobile for taking up this kind of an area for discussion. We have also assembled very good set of resource people from Anna University, from different NITs, various IITs, as well as from the industry. So this is all very good beginning for the growth of the department as well as knowledge sharing. There is one point that I want to stress at this time. Ishwari Engineering College is ready to look outwards. We are interested in having collaborative work, joint research work, joint paper publication, joint product development, internships, training programs, with various other academic as well as industrial concerns. This is the message that I want to spread out today. We have been having very good industry partnerships, academic partnerships. We want to enhance on these areas as well. I also want to thank our Chief Director, Professor Dr. N. Sethuraman sir, our management team for being a constant support for us to do lot of activities. This is the oxygen. The ambience is the oxygen by which we are able to do so many activities. And as a matter of information, Ishwari Engineering College is autonomous institution. So we can design our curriculum, our regulations, our syllabus. So meaning which we are ready to fine tune our activities to meet the industry or current state of art learning. Needless to say, automobile engineering has undergone a metamorphosis. Now, an automobile manufacturing company is not afraid of another automobile manufacturing company. They are afraid of Apple. Apple is making cars. They are afraid of Tesla. With literally no great infrastructure, cars are being rolled out, vehicles are being rolled out. So things have changed a lot. Today, in the automobile, less than 10% is mechanical. Predominantly, it is electronics and computer science. So these are all changes. Our curriculum reflects it. We have very good industry BOS members, academic council members. We have made many changes. I also wish to mention that we are a smart campus, green campus. Then our students actively participate in many different competitions and they win laurels, bringing pride for themselves, for their families, as well as for the institution. So once again, I want to thank the HOD and his dynamic team for putting in all this together to make a great event. And I want to thank all the resource persons, more so our chief guest today. Thank you so much, everybody. Jai Hind, Namaskar.
Thank you, sir. Thank you for your provoking address. Now, we would like to invite our Vice Principal Academic, sir, Dr. V. Ilango, to say a few words.
Good morning, respected chief guest of the day, respected chief director, sir, respected principal, dear automobile HOD, my dear colleagues, and participants from various institutions. We welcome you for this FDP program on advanced materials and manufacturing technology. As pointed out by our principal and the chief director, today the industrial environment is completely changing. No more a mechanical engineer, no more an automobile engineer is going to manufacture cars. The other branches, the other fields are gaining control over the manufacturing sector. So in this scenario, the automobile department is conducting an FDP program. Definitely, the different speakers who are going to talk on the different field, as discussed with the automobile HOD, only eminent persons from IITs, NITs, and Anna University are going to give or going to deliver lecture. I request all the participants to make use of the resources and gain as much as possible so that the automobile department, it can conduct more such program. It will be an encouragement for the department and they'll be conducting more and more such program and more people will get benefited. And talking about the automobile department, as pointed out by our chief director, whenever it comes to development program, whether it may be faculty development or it may be student development, always the automobile HOD is there. Recently, he has conducted a lot of programs for the development of the students, along with Ashok Leyland. Series of lectures. Eminent person from Ashok Leyland, they were delivering lectures for the benefit of the students. And now he has started a series of program for the development of the faculty. I really appreciate and congratulate the automobile HOD and hope this FDP program will be very successful and more and many more faculty will get benefited because of this FDP program. Thank you, Automobile HOD sir. Thank you for giving me the opportunity. I wish all the best wishes. Thank you.
Thank you, sir. And now we would like to invite HOD Department of Automobile Engineering, Dr. Vetrivel Chilian, sir, to say a few words.
Vanakkam and happy morning. I will not like to take much of the time. So I wish Dr. Satyamurthy sir and team congratulate them on putting together such a wonderful program. So I hope all the participants benefit from this wonderful association of this and the expertise of the faculty members and experts who are going to join. So I congratulate the team for the wonderful program and hope all the beneficiaries take the full advantage of these programs and get benefited. Thank you. Have a nice day. Thank you, sir.
Thank you, sir. Now we request all the participants, please be online. The first session of our FTB will start after the vote of thanks. Now we would like to invite our FTB coordinator, Dr. P. Sarangabani, sir, to propose the vote of thanks.
The best and beautiful things in the world cannot be seen or even touched. They must be felt by heart. Thank you is one such prayer among them. I consider it a great privilege to propose a vote of thanks to all the dignitaries who have witnessed it as a memorable and successful event. My heartfelt thanks to Chairman Dr. R. Shivkumar sir and Co-Chairman through S. Niranjan sir, and also thanks to Chief Director Professor N. Seduraman sir and Director for the encouragement they will give in all our programs. We thank them for their valuable suggestion and the incentive proposed. Today, my words are not enough to express the gratitude on behalf of our department. I would like to thank our chief guest, Captain Dr. A. Suresh Babu, who graced us with his thought-provoking address, set a perfect platform for our program. I would like to thank our beloved principal for all the words of wisdom that radiated a source of energy within us. We will ever remain grateful to you and we thank you for being with us today. And also, I very much pleased to thank our beloved Vice Principal Sir, Dr. V. Yelango. Thank you, sir. And I also wish to express my gratitude to our HOD for his minute-to-minute guidance and support and always stand by us, guide us, lead us, and motivated us. We feel proud and thank you for making us feel happy with your presence to this function. And also, I thank to Dr. M. Vetrivel Chilian, sir, Head of the Department, Mechanical HOD. Thank you, sir. And I would like to express gratitude to all the faculties for providing support and encouragement at every point. I would like to thank the heads and staff members from various departments for their kind cooperation towards this FTB. Next, I would like to thank energetic participants from various colleges who have been participated. Thank you to one and all. Please kindly stay back for expert talk. Thank you, sir.
Thank you, sir. So now the session hand over to
Dr. Suresh Babu sir.
Thank you, sir. Thank you all. Thank you all the HODs.
So thank you, coordinator. Coordinated well their inauguration, and I hope it has to be started at 10 o'clock. Now 10:15. I hope some more time I will take beyond the scheduled end of the session. Forgive me for that because I may have your own schedule on that. We can move to the lecture. Is it visible?
Yes, sir.
So I've been associated with for the past 21 years the College of Engineering India, in which Department of Manufacturing Engineering. So it's a very old engineering college with which I'm proud to be associated with this college and the department. I have been trained with many stalwarts in the field of production engineering. Earlier, it has been later converted into manufacturing engineering in the year of 2002. We have, so this slide is particularly for to open up what are the facilities we have. As our principal said, these facilities are open to everyone in the country or outside the country even for collaboration, as well as you can use our facilities at nominal price. Not be much be costlier for your own researchers. Okay, so we have very good facilities of additive manufacturing. It's worth of 3.15 crore. From there we have 5-axis ordinary production type lathe with coating systems and measurement systems, which has been shown in the slides. So all these facilities, in addition to some more facilities, are there. Cannot put all the facilities here, so you can use any facilities here for our own research work. So the topic given to me is advances in welding, and I excuse some of them who attended already in the same talk that has been delivered 1 week before in SRM. SRM IST. Since the talk is picked up by Professor Satyamurthy for this program, because of the importance of the processes, the advancement in processes has to be part of this program theme, fit into the theme of this program. So once again, I'm delivering the same here. So whenever we talk about advancement in any field, there are some questions which comes into my mind or our mind. Is there really any advancement in the field? So that has to be answered. Is there technological advancement or process advancement? That has to be answered. If there are advancement, is this advancement is are really having impact in many sense. So you are going to see those what are the impacts which need to be considered, as Professor Sitharaman, the director, said. The impact even in environment, we have to look at as sustainability gain importance in the schedules of UN. As far as the process is concerned, we have a number of processes which gained a lot of changes from original introduction of the process introduced with electric arc. It has been generated with the bare wires. In the 1800s, there were bare wires were used to create an arc, and metal has been melted and has been joined. And the refinement which has been happened in many sense. It may be due to the defects which are or the quality of the joining which were made, which has not been met the requirements of applications. It has been gained importance for protective welding with which covered electrodes. Later, that semi-automation which constitute that these covered electrodes which of defined length cannot be sufficient to address the issue of continuously supplying the filler metal into the area, but we have to keep the protection of weld from accelerations and avoiding the defects associated with. So there were developments with submerged arc. Then there were developments through EEG or MIG. Later it has been converted by using active gases like GMAW or GTAW. And further refinement of this, which has been due to the size of the welding and associated developments in the materials point of view, which constitute the development of processes like plasma, electron beam, laser beam, and associated processes, ultrasonic. Then as the environment constitute these processes which were ensured environment. In addition to that, some more processes need to be invented for having the attaining the melting temperature and go back to the original after solidification, original room temperature. There were a lot of things which has been constituted the complexity which are associated with the weld thermal cycle have to be eliminated from the processes. Friction stir friction welding in general, those group which has been evolved, and these processes are now called as green processes as well as the environment impact is concerned. So from electric arc to the processes which were seen today, really there were developments which has been happened. So advancement happened, and as we listed the reasons. So what is the impact of this? So there were developments, but what is its impact on economy? What is the cost associated with these processes? Really, as engineers, we are worried about. And what is its impact on the environment? So there were a lot of exercise made by all the governments, all human beings are worried about what is the impact of anything, man-made things which has been happened. So we are very conscious on what is the impact of its on environment. That has been worked out. And we cannot compromise just for the sake of economy and environment, the quality of product which has been produced, the consistency with which it has been carried out, and economical point of view, the productivity has to be maintained. And associated, again, it is look at the economical or business point of view, associated advancement is there any association with the development of new tools and associated businesses. And whatever the developments or advancement which has been happened, it's much more intuitive. Immediately it has to be recognized. Even though any logic is explained, but it should be logically convinced. And it should be easier to use. So the complexity should be reduced in carrying out or using the technology or using the product for the particular application. So the impact associated with any advancement have to be answered, though that is the one question that has been come to our mind. Now come to the advancement. I hope I have justified what are the questions which has been generated to justify the advancement in a process. When you consider advancement in welding, what are things we will always keep in mind all the questions have been answered in the coming slides. You can relate all the content which is going to be discussed in the coming slides, which will be related to that. As far as the advancement in welding, the emphasis is on automation and associated things, robotics. When you talk about robotics, whether the solutions can be made with a combination of things, man and robo, or robo with robo, collaborative systems. The robotics in place or automated welding is in place. Whatever the control requirement, whether it is going to adjust with adjusting as it has been done by a human being, by his own fusion, that he will adjust, and by his experience, he will adjust by all the senses. That has to be incorporated by having adaptive control. What is its advancement? So it is not only the process advancement. When you train the people for any particular process, whether we are going to consume the time on training by spending all the resources which are available for carrying out the processes, need not by having VR, virtual reality, can do the training, you can give the experience for the operator or a welder, the real process environment can be simulated so that he can implement whatever the learned things during virtual reality in the actual welding processes. And it can be extended to research and development also. As far as the productivity is concerned, we can have tandem arrangement of multiple hits, thin wire, will have compensated heat welding techniques, hybrid welding techniques to use the advantages of multiple processes. And the last, but it is it cannot be considered least, safety of the people who are connected with the workers, the protection technology. So the advancement of advanced screening or advanced protective clothings or advanced protection which has been made part of equipment to protect the welder or worker from getting into accidents and associated indirect and direct cost. So that finally it is the business which will lead to the profit, which is not based with solving the cases of any accidents which has been happened. So advancement is not only with the processes, the advancement it is along with protection devices which are used. So this is very common, and most of you know the different levels of automation, with very hard automations, very rigid automations where we cannot make any changes after its installations. Inflexibility, not able to change the product as well as the process. Or you can have semi-automatic programmable automation by changing the program where I can do kind of changes which can be. Okay? It's a mixture of hard as well as the hard automations. You have having the soft solutions to the program. But it gains a lot of labor intensive when considered with the fully flexible automations where it consists of intelligence built up. A seamless, smooth changes which are required. Particularly in welding, we can see that it will not be very mass processes, so that the flexibility associated with a flexible manufacturing system can be implied. Welding is very much suitable. When you have much more flexibility to be added with the automation along with robotics can give. So when you talk about welding automation, it can start with semi-automatic welding or completely automated flexible welding systems where the robots also incorporated. Or it can be called as remote welding when you do welding away from the place where you are going to operate it, control it. Or robots can be programmed, robots alone can perform the welding. So these are the part to be discussed. I hope the time is available is very less, within which whatever we can discuss, we can be able to. What is the welding system we have to adopt? Automated or semi-automated or manual? It depends on what is the profile to be welded. What is the quality with which the welding should be made? Or how many number of skilled persons are required? So based on that, we can go the decision making. If it is very simple, ordinary jobs, we can go with handle with manual welding. If it's a little bit complex, we can go with some kind of positioners and manipulators in place. If it is very complex systems, we can go with robo system. So historically, this robo system, which is used for welding, should be justified, and it has been mentioned by peers in 2003. It has lies in between the lines which are made when you draw between the cost and the value of production. You can see that there is a linear trend in manual content of work. It has been increased with increasing volume, and cost is also increased. When considered as robo as for welding, decreasing cost with increasing value, and hard automation also shows the same trend. But there is a shift in hard automation and robo. Robo can be incorporated even for small volume of product. And compared to the hard automations, because it involves with the medium and large scale, so because your investment has to be justified. So along with this high volume or the cost associations, other things you need to be considered, whether it is repetitive, fatigue associated with task, whether you have in-house programming expert or in-housing welding expert. Those are the points to be considered when you employ the robot welding systems in your organization. So these are the key factors need to be considered. Talk about the generations of robotic welding system. What is generation which is now in its place is third generation. What was the first generation is, if you consider two-pass welding system, the first pass is to learn what is the geometry. This is an example. There are other factors to be considered. And second pass is what is the actual tracking, actual welding which has been happened. With the developments, the second generation which can address this problem simultaneously, learned and tracking cases are together carried out. In the third generation, so in the current generation robot systems, the adaptive nature of system which has been employed, which constitute both the things which has been solved together as it has been done in second generation. In addition to that, it will adjust itself with the unstructured environment. Any changes in the geometry, very rapidly it will respond to the changes. So there is a kind of system which has been in place now. As far as the equipment is considered, so of course you need to have a knowledge in welding, in this robots, sensor technologies, control systems, and artificial intelligence. All these things together will be compiled, and you can be able to have a third generation welding system in its place. And So based on the economy, we can have different kinds of systems in our organizations. We have to look at if a automated system is in place, what is the base platform, or whether the positioner or fixtures for the workpieces, which is really going to constitute the proper welding in association with the robots or other automated system in its presence. Because there were statistics which tells about 40% of the defects due to the work holding and its manipulations in the manufacturing processes. So of course the positioners or fixtures are having greater role when you talk about a very complex welding requirements. So the master control of a robo or master control of any automated system should consist of power source, should consist of feeding the filler material, should consist of robo itself, which has to be operated for its motion, and whatever the arc which has been generated, that has to be controlled. It may be of different versions of control by keeping the distance as well as by keeping other process parameters, or workpiece movement, motion control through positioners or any other devices which are in place. As far as the robo is considered, the following parameters criteria can be used to define how many degrees of freedom, what is the flexibility associated with, what is the kinematic structure. Kinematic structures which will be here, it has been considered based on what is the process which is going to be used, whether it is fusion welding or solid state welding like friction state welding, a series or parallel type of robo. Drive technology, which hydraulic or electrical actuators. Workspace geometry, what is the reach of this? It may be different with the different kind of kinematic structure of robots and other associated elements which are present in the robot. Motion characteristics, whether it is continuous or intermittent motion, which has been given. For example, just as mentioned, RAS robots with revolute, jointed arm configuration are the most commonly used type of robot in arc welding. So there are other robots we are going to see in coming slides for other processes also. There are three phases of preparation or whether it is going to be implemented, and third one is it has to be analyzed for its purpose. It is true with any processes. Here also, when you go for fully automated robotic welding system, whether there is any intervention is needed by the welding operator to set up the parts, to prepare the devices for welding, robo or preparing robo program or designing welding parameters, feeding those parameters, checking whatever the consumables which are present are available or not. Or if any CAD CAM which has been used, whether it has been going to generate the program or any offline programming has to be used. Pre-program is available, and if it is placed online, and consequently the fine-tuning requirements of these pre-programs for the changes which are being or compatibility of equipments which are present there. All these consist of a preparation phase. And during welding, the torch orientations, and it has to be monitored for its trajectory. The seam has to be tracked, and real-time measurements of all these things which constitute adaptive behavior of welding. And in analysis phase, it's a post-welding phase generally, but nowadays we can see that the analysis can be part of online and part which has been executed offline after post welding, because after it reaches the original temperature, we need to have some kind of analysis. So the advancement in part of sensors which constitute that whether it can be done during the welding, or the information gained during the welding can be associated with after attaining the room temperature, the results can be used to calibrate for the next time. It can be corrected. So kind of analysis is required. That is the last phase of the operation. As far as the robotic programming, we have manual methods. We can generate, we can write some codes, and it can be used. We can use PLC to program it, and it can be generated. It can be used for control systems there to operate it. You can have online programming like walkthrough or lead through or teach pendant, or offline programming where computers are used to have programmed, simulated, and then it can be used directly the robots. So the category of robotic programming, which includes lead through or walkthrough, teach pendant. The major drawback we have to consider that it is quite inflexible. If it is very simple robo parts, it will be able to do that. In online programming, when you talk about walkthrough or lead through, the operator who moves the torch manually through the desired sequence of movements, which are recorded into the memory for playback during welding. As it has been mentioned earlier, it is having the limited flexibility. If anything which has been happened during the welding due to pre-machining or fitting of workpieces, or any thermal associated problems which has been gained due to the change in gap, all these things cannot be addressed with the, so the motion is planned and just playing back. So it will not adjust itself for the requirements. So you have to work on that. You can have teach pendant to teach it. So you can move the manipulator, the program, the robo arm by using a teach pendant, and through the sequence of motions and the points were recorded, and again it is playback during the program execution. So these are things associated with the online programming compared to offline, where, as I told, we have computers where all the trajectory which has been planned, has been programmed, and it has been simulated, and later it has been transferred through Ethernet communication networks. Just we see a video and then we move on to the next discussion.
Online programming occurs when the robot is online or in an operational mode. The two types of programming we will discuss here are teach pendant programming and lead through programming. A teach pendant, also called a teach box, is a handheld control and programming unit connected to the robot via a cable. Teach pendants can be touchscreen, keyboard, joystick, or other computer interface. All typically have an emergency stop button since the robot is operating with the technician in the work envelope. More modern teach pendants can also be wireless. Teach pendant programming is a method by which the operator steps the robot through the program point by point by point while recording the coordinates for each point. The technician has the ability to send the robot to a desired position, inch, or jog to adjust it, and then record the point. The technician may also change the speed, since a low speed is usually required for careful positioning or while test running through a new or modified routine. ANSI standards recommend a speed of no more than 10 inches per second when programming. Once the technician has recorded and tested the program, the teach pendant is disconnected and the robot can operate the stored program at full speed. Teach pendant programming is often associated with controlled path and point-to-point control. Lead-through programming, which is typically associated with continuous path control, is a method by which the technician physically guides the computer through the desired program. This method, also called lead-through-the-nose programming, is used most often in spray paint and welding applications. It requires very little programming skills and allows experienced technicians to accomplish the work using the robot while the controller records each step. This method typically takes less time to accomplish than teach pendant programming. Online programs can typically be edited for speed, point error correction, and small modifications once the initial programming is complete. Advantages of online programming include ease of use, little or no programming skills required, and the speed at which a program can be created. The disadvantages of online programming are the requirement to shut down the production line while programming is occurring, and that the technician typically has to be in the work envelope while the robot is operating, which exposes him to greater risk of damage.
As it has been mentioned, the advantage are there, the disadvantages interfere or getting to the work envelope, but there is a chance for accidents, as well as there are disturbance to the regular work which is going to be carried out. So that has been eliminated by having offline programming. So there are problems even in robot welding that has been discussed because cannot always look at the positive side of anything. We have to look at negative side of that so that we can address and we can come up with some solutions. As I told, if any fixturing part of it, the workpiece, the variations which constitute that no, you cannot exercise of proper control over there. There may be fluctuations which will lead due to the primary manufacturing processes which are carried out. As mentioned earlier, the workpiece fits, improper fits, which may constitute some kind of problems with welding. And the time and effort which were taken for preparation with the robot is quite high when you talk about low volume manufacturing. Or kind of repair work, it's called hardly very less work need to be carried out. For that, we have to spend a lot of time. And it requires proper preparation, like proper joint design, consistent gap conditions have to be maintained if it is a repetitive task, and the gap tolerance must be maintained. And if there are variations, so that has to be filled with proper sensing technologies should be in place. It is cost associated. And the cost association with all these technologies, which is incorporating with robots and its sensors, have to be worked out with proper return of investment, which is very much essential as business point of view. And possible shortages of skilled worker for programming and other related areas. And the adaptive options of adapting human behavior for decision making, that has been looked at. Some of the solutions already has been in place. and the presence of robots in some of the areas like which is of very much complex to be take the robots there to make the weld like pressure vessels, interior tanks, or some kind of stick bodies where you cannot have very easily due to the constraints in the heat. And intelligent systems availability and its compatibility with the controller and other hardwares which are present. So far, we can see that even in the developed markets, it is not very well integrated due to this mismatch, and it may lead to unstable performance. And it is not only the first time of installation, and we have to understand that the system has to be maintained for the entire lifetime. That needs a lot of attention, a lot of considerations for its stable performance by having compatible devices availability for the entire lifetime. As just mentioned, we need to have a lot of sensors for the changes which are being there to rectify it during the process itself. We need to have kind of sensing devices which will sense and adjust the system or inform or warn the operators for the correct doing of processes. Detect and measuring few process features and its parameters, joint geometries, weld pool geometry and its locations, having control exercise during online, and the quality evaluation of weld made during inspection. It may be online or offline inspections. So when we talk about sensors, ideal sensors should measure the weld point. There should not be any tracking misalignment. And it should be anything which has been happened should be detected in advance, like the collisions or what is the start point, what is the end point, what is the constraints which are there, hindrance in the path, all those things which has been detected in advance and it has been given for making decisions, and should be as small as possible to accommodate the welding system, which will not constitute some more problems to be gained due to its presence. So that should be avoided, and it should be immune to the processing nature. Okay. In the weld, we have a lot of temperature variations, so that has to be incorporated during the selection of sensor itself. So we have a list of sensors, how it can be used with welding. Is important. Its drawbacks have to be considered before one has to be selected for the purpose. You have sensing type touch sensors. It may be capacitive or resistive. Can be used for accurate learning of path, but we have to consider that elastically, if the component is there, that has to be reflected on the touch of it. So the repeatability, when you consider it, is very poor because of the touch nature of these sensors. So the wire tip, the gas nozzle cancel as a sensor here. They have qualities which are there for capacitive or resistive can be incorporated there. So it is low cost, as just mentioned earlier, variety of joint geometries for which you cannot have a generalized sensors. You have to go for different sensors, as which is true for inductive sensing also. A pickup coil can provide entire crossing vertical direction also in addition to the lateral directions. The signals can be corrected, but again the drawback which is associated with the contact sensing, which is there with this also. So we have to devise a customized sensor with inductive also. As far as the capacitive is considered, it is very hard for us to correct the signal in two directions. So the variations which are present in other directions, when you have the measure in one direction, it cannot be adjusted so that it will be reflected on its measurement accuracy. And acoustic sensing, and can be used very well to inspect the weld, any obstacles presence. But we have to remember that the temperature depends on sound waves. The sound waves, the speed of its movements is affected with the temperature variations. So that has to be accounted for or calibrated. These sensors have to be calibrated with this. Optical sensing is another one. Where you can have the geometrical recognition is very easy, but it's if any hindering in its path, the accessibility limitations which constitute that it cannot be used for some purposes. And we have to, by the process nature, we have to take care of the lenses which are used with this optical sensing for its performance. It has to be protected. So these are some of the examples where lighting source, optical sensors with the lighting source of LED or laser can be used. It's three types: through beam, or retroreflective, or diffusionary reflection sensors. The through beam receiver or emitter is there, the retroreflective one kind of reflection device which can reflect the light and can be used to measure it. The obstacle detections, the presence of workpieces and its obstacles, which can be used with diffuse reflection sensors. In the acoustic, we can have kind of thick variations, thickness shear mode, or surface level, or shear horizontal, as it has been mentioned, the plate type of it, or we can have flexural type of it. As it has been considered in most of the cases, acoustic, which has been considered piezoelectric or magnetostrictive, but it can be a capacitive or optical or electric that can also be used, and its associated disadvantages has to be gained. So more informations are available in ZOO 2019. You can refer this for the sensors which are in place now. Part of robots can be used for many purposes, not only welding. So on the spot sensing, we need to have weld pool as well as through the arc sensing as well as weld pool have to be observed. So the images, the video measuring system, the cameras, the development of technology which is associated with the image generation and its analysis, which will use to track, or based on clarity of images, the analysis give better inferences. And through the arc sensing, it has to be oscillated through the entire prepared edges, the bud welds. It is not suitable for sheet metals because of we cannot prepare the edges so that we cannot have the oscillations to be in place. And we can see that it cannot be established at the starting point, so the starting point cannot be measured there through the arc sensing. Some of commercially available thing. If you look at, there are two ways in which it has been used. One is seam finding, another is seam tracking. So the Metavisions corporations or Servo Robo Incorporation, they have come out with some kind of sensors in which I can find seam finding can be used for adjusting the robotic manipulator or weld touch to the right position or orientation in relation to the groove which are present. It is just prior to the welding. And this can be applicable where a series of welding where real-time tracking is not required, we can go with seam finding. That is enough. So the selection of sensors is based on what is the purpose for which we are going to use. Seam tracking is going to be really useful in the case of real-time tracking is required. For example, there is an uneven heat transfer or distortion occurred due to that variation in gap size. It has been adjusted, or the edges which are prepared as target. We have to go with real-time seam tracking sensors. So automatic correction can be placed. Less stringent requirement in case of the fixtures. Parameter adoption can be possible. Programming time can be reduced. Defect rates can be reduced. Quality can be improved. And can also be used for the same purpose of seam finding. So this is another approach, adaptive control. We need to have adaptive control based on the changes need to be incorporated during the process. It can be used to find joint, root penetration requirements, contact feet placement and seam tracking, and filling of those joints, which has been mentioned. So you can very well understand by having the picture there show you. I can this is the picture. You can see that the adaptive fill mode, the variation in the top, you can find that we need to have kind of variation in the air path. That has to be, adaptive technique is required to change, adapt to the requirements. So the adaptive control is a loop where the adjustment has to be done in the process parameters like current and voltage, or the torch has to be adjusted with vertically. So the end effector's path and its orientation has to be adjusted with high precision. So welding parameters have to be adjusted in real time. So these are the two things which can be adjusted with adaptive control. This is an example table. You can see that if it is measured as 10, what are the parameters is used? It has been picked up from the adaptive table and can be supplied to them. So one need one if wanted to use the adaptive, he has to have a proper database with what is the material used, what are the fill-in materials, what kind of parameters has to be adjusted. So the quality loops has to be established as per the quality standards for the particular process, as it has been shown in the pictures. You can see that quality loop 1, quality loop 2, how the welding quality has been measured with control which has been exercised at various levels. So the preset nominal values which has been measured and compared with these preset values, and to make decisions whether it has continued till it reaches or it has been gone there, or it has to be stopped there. Sometimes it has been used to give the warning also, and the development of non-destructive testing methods is also be useful for quality monitoring in addition to the adaptive to ensure the quality weld. So you need to have quality monitoring in place with the help of non-destructive testing methods without any contact which has been made with by taking pictures or by causing lasers, we can be able to have some kind of monitoring so that you can have what is the deviation which has been found by having tolerance bond established compared with the actual path. You can make adjustments there. Our system can itself make adjustments. So this is a weld seam inspection device just developed by Electronic, a camera-based sensor with a computing unit, fully automated both in 2D and 3D with machine vision. And we used to find out defects in real time and can be used for statistical evaluation for quality monitoring. Thermal profile is another which has been developed. EPSI is one kind of device which can be used. What is the thermal zone? What is the maximum temperature? Whether the penetration, the weld seam offsets, or hole, or any other defects can be related to this thermal details which are available, which are scanned through thermal profile scanner, can be very much useful for creating a database and controlling the process. It can also be used for online as well as the analysis, which will give a complete picture of the welding carried out and what are the adjustments have to be made. And Robofind is another sensor, Sense IDV or Robofind SFDHE. The other commercial examples of sensors for seam finding as well as seam tracking work can be carried out with all the advantages already just been mentioned. So it has been a product of Servo Robo Incorporation. Vision sensor can be used with various stages as it has been shown in the picture. You can see that what is the time duration with which these sensors can be used. If you look at the touch sensing, nearly half the time which has been elapsed for laser vision sensing. So the time saving is possible with this, with associated other advantages. So power track is one kind of sensor. The trajectory of the torch just be modified, can be fixed at the near the torch. And you can see that it is very immune, which is very close to the arc. So it should not be get affected with thermal changes which has been happened nearby. So it is immune to the arc process. So the spotter, which is a result of welding, should not affect this sensor. It can be integrated with other units of welding, or even cameras can be with control in it, or the software should not be get affected. It can be used with various light conditions, which is very much essential in case of welding. So at the end, we can be able to have a reliable joint configurations can be established. So it can also be used with high-speed welding processes like twin arc or hybrid welding techniques. It's not alone with a single head welding. And the large library which is provided with the information available, which can be used with various geometries. It can be suitable for adaptive welding module. And Laser Pilot by Metavisions, in which Laser Pilot MTF, Laser Pilot MTR are the product. So MTF is to find the seam, and MTR is for the seam tracking operations. Again, the errors due to thermal distortion can be corrected with, so it does not be get affected with. As I told, the first one is Pilot MTF, which has been used as an device to find out the correct path, correct placement of torch, and MTR has been used in real-time tracking. Apart from this, circular scanning system, which works exactly as the principle as in your metrology lab, we might have gone through the autocollimeter. The same triangulation principle is used with offset axis lens. So this has been used with CCT detector and can be rotated inbuilt motor which rotates the off-axis lens. So a conical scanning have been done that will be used to detect. So it shows that as per Berquist, it shows the increased detection. He used his studies to prove that this CSS is having much increased detection ratio compared to the other measurement techniques. And the advantage is highly reflective materials such as aluminum, where the laser, which will have some kind of the reflections which will affect the function of lenses, where can be used very well. And TKDN is another lens sensor which is exactly operated with the CSS mode, which has been built with the AVB 2416 and aluminum C pillar in Jaguar Sports Car XK is an example where the applications made with this sensor. So where the joint made in this car need to be completely hide, there should not be any visible external joint. That has been achieved with this kind of arrangement made with Robo as well as the sensors which has been in place. And can be used to position with the depth and orientation measurements. And the time duration which constitute very less. And allow us to use an optimized path in conjunction with the Robo which has been used, ABB 2400. So apart from this, ABB Weld Guide 3, through the seam tracking by oscillating in directions parallel to the groove which has been made. It can be function in two mode, task to work mode and centerline mode, which has been shown here. So vertical adjustment and the horizontal adjustment, which makes that it can be useful with two different modes and two different kind of adjustment measurements have to be done. You can see that it can be very well suited for adaptive mode, multi-pass modes, where you can adjust it and you can have the thermal management with changing requirements that can be done. Just before this, make the conclusions, I wanted to show a video where how this
The essential task of a sensor system is to compensate the deviation between programmed path and real workpiece, which were caused by tolerances during prefabrication and heat distortion during welding. The sensor ensures the weld quality and increases the flexibility of the robot system. The arc sensor determines every necessary information from the arc. At the same time, it is active during welding. The calculated correction data directly influences the path planning of the robot. The arc sensor compensates the tolerances of the prefabrication and the workpiece deformations because of heat influences immediately. The welding torch oscillates during welding. The sensor scans the welding current at both edges of the oscillating movement. Ideally, the welding currents are the same. If there is a difference, the welding path is corrected until the height of the two welding currents is compensated. The weld seam is in the groove of the workpiece. Measurement is active during complete welding, thus ensuring an optimum weld position. In addition, the sensor data serves to calculate and correct the distance of the welding torch if necessary. A lot of measuring points guarantee a direct robot reaction and ensure a perfect position of the welding torch to the workpiece. The robot controller allows saving the correction data, which can be used in the further program flow. When welding a multi-layer V-weld, the system saves the correction data which were measured during welding the root pass and uses it to calculate the cover pass position. So the path planning is directly matched with the determined sensor data. You benefit from the minimum time expenditure. There is no interference from attached parts. Besides, you can use the correcting sensitivity to adjust the sensor reaction. All components are perfectly matched to each other. Power source, sensor and robot communicate via fast interfaces and ensure short reaction times. Tell us your welding task and the request tolerance compensation. We analyze all parameters and develop a practical implementation for you.
So as conclusions, so robotics and sensors together with their associated control system have become important elements in industrial manufacturing. So continuous development, robotics, sensors and control systems, which makes that the next level solutions be possible. And variety of sensors are available for various measurements, whether it is parameters or geometry measurements at room temperature as well as air temperatures, so that it is possible for us to go with proper control can be exercised with the proper seam finding, seam tracking, implementing adaptive control or making monitoring there. But we cannot neglect there are still some issues associated with robotic welding. Since this is a costly affair, so as from the research point of view, from the Indian academic research, there were very rarely it has been attempted by our own researchers. But based on the sources availability, one can take the job and can proceed very well with various kinds of research possibilities in these areas. The calibrations of sensors are how to efficiently go with the control exercised with the trajectory or path planning, algorithm developments for the control of fluids with various process requirements. So as during my inauguration talk, I did that the various technological developments is an upfront as we used for the advancement for the improve the human life. So thank you very much. If you have any queries with whatever the little knowledge I have, I'll be able to answer.
Thank you, Professor.
At that time. Okay.
Thank you, Professor. It was a wonderful session and the explanation was very vast, sir. Participants.
Kanishka.
Yes, sir. Participants, do you have any queries to ask to Professor?
Any queries? Any clarifications required? Any interaction? Thank you, Professor.
Okay.
Thank
If
you.
you have any
Thank you.
interactions, if you're not able to clarify here, you can contact me. You can note down my email and you can contact me at any time, any point of time. Use of our facilities as well as any queries associated with this presentation. And I hope I'll be able to collaborate with all of you in the coming days. My email ID is subhaseg@gmail.com, and other contact details you can find in our websites.
Thank you, Captain. Thank you for wonderful presentation, amazing presentation about advanced welding process. A really very impressive expert talk today, Professor. A good start is half of the work. Today, we start with this wonderful presentation by Captain Professor Dr. Suresh Babu, sir. Thank you very much, professors, for your wonderful presentation today. Thank you, Professor. All the participants, the feedback link will be provided another 2 or 3 minutes in this group. Please kindly fill this feedback link, and based on the feedback link attendance only, we are provided the certificates. 80% attendance is very important and mandatory for this faculty development program. And end of the program, we will conduct the test. Minimum 60% of mark and 80% of the attendance is mandatory for this 2 weeks faculty development program certificate. Thank you, one and all. Please be patient. Stay safe. Thank you, Professor.
Thank you. Can I leave?
Sarangmani, kindly share this link. Share the feedback link.
Yes, sir. dear participants. Feedback link will be shared on the afternoon session. Okay, sir. Thank you for the participating in the FTD, sir. Feedback link will be shared on the afternoon session, sir, for both sessions.